Hi everybody, this is Mr. Yeoman, and today's topic is percent yield. So you've been working through talking about limiting reactants and excess reactants, but one of the things that can result from figuring those items out is that you can calculate a percent yield, which is really just saying that in lab you're going to get a certain amount of product. Now you are expecting a certain amount, but that never actually happens. Think about all of the billions, well, more than billions of molecules that are interacting, and you have to have every single one of those interact in order to get the theoretical yield that you had calculated. But that never really happens. So the way that we figure out your percent yield is we take the actual yield and we divide it by the theoretical yield. Okay, and so that's going to give us a decimal, and then we're going to take that times 100. So just the same way that you would figure out the percentage that you got right on a test or a quiz or something like that, you do the same thing here. The only difference is that the actual yield is coming from the lab experiment. So you're saying that this is exactly how much I was able to recollect, and I'm measuring that on a scale. The theoretical yield is what you figured out on paper, that you were able to go through and mathematically calculate this is how much I should have gotten. So theoretically, I should have gotten this much product, but I actually only got this much product. And so when you divide that, then you're able to get a percentage. So here's a sample. So when 45.8 grams of potassium carbonate reacts with excess hydrochloric acid, 46.3 grams of potassium chloride are formed. Calculate the theoretical and percent yields of KCl, of potassium chloride. So what we're trying to do is it's asking us to do two things. We want to calculate the theoretical yield and then also the percent yield. So we need to identify information. So using the DICE strategy, we just determined what the question is trying to answer. We're trying to calculate the theoretical and percent yields of potassium chloride. But now we need to identify the information, so our knowns and our unknowns. And so our first known is we know how much potassium carbonate we are going to be reacting. We also know that there's an excess amount of hydrochloric acid, so we don't need to worry about it. Previously, when we'd been calculating limiting reactants, we needed to know how much potassium carbonate there was and how much hydrochloric acid there was. But in this case, they're saying you have way more hydrochloric acid than you need, so we don't need to worry about that side. So we're only going to have to do one problem in order to do that. On the other side, we know how much potassium chloride was actually formed in the reaction. So that's going to be our actual yield, which is 46.3 grams. I've identified that in the problem. Now, the unknown, the thing that we need to find is the theoretical yield of potassium chloride, because in order to get our percent yield, we need that theoretical yield anyway. So that's our question. We need to find that part out. Okay, so here's our same balanced equation with that information on there. So our actual and our unknown and the amount of reactant that was provided to us, the potassium carbonate. And so we can set this up just like we've done every other stoichiometry problem. So we're going to start with what we know, which is our 45.8 grams of potassium carbonate. Okay, so in order to determine that theoretical yield, we'll take that information and put that down. And now we're just going to set up a regular stoichiometry problem. So we need to get from grams of potassium carbonate into grams of potassium chloride. So as we know, going from grams of one substance, we need to get into moles. So we need to convert into moles of potassium carbonate. So we're going to take the molar mass or formula weight of potassium carbonate and put 1 mole over 138.21 grams, because that is the formula weight. And that puts us into moles of potassium carbonate. Now, that's not really what we want to have. We want to be in grams of potassium chloride. So we need to get from moles of one substance into moles of another substance. So we need to use the mole ratio. Well, we're going from potassium carbonate into potassium chloride. So we need to look at our mole ratio. So there's no coefficient in front of potassium carbonate, so that would be a 1, and there's a 2 in front of the potassium chloride, meaning that our mole ratio is 1 to 2. So we put that in there appropriately. Now we're in moles of potassium chloride, but we really need to be in grams. So we do the same thing that we did in this step over here, which is use our molar mass or formula weight. And we're going to put that in, and now we can just calculate across and determine that we have 49.4 grams of potassium chloride as our theoretical yield. Now, some of you are probably already taking a look at this and saying, well, these numbers are not the same. And as I said, very rarely in lab do you actually end up with the theoretical yield. It's usually much less. We'll talk about some situations where it might be more. Okay, so we cancel out our labels to make sure that we have the correct label. Yep, everything else canceled out, so we have grams of potassium chloride. So now we've determined our theoretical yield, which I plugged in right underneath that potassium chloride up there. And so now we can determine our percent yield. Okay, so our percent yield is the actual divided by the theoretical. So our actual yield is 46.3 grams, which was provided to us in the initial problem. And our theoretical yield we just calculated, so that would be our 49.4 grams. Okay, when we calculate that, we're going to end up with a decimal. So we're going to need to take that times 100, and that will give us our percent yield, which is 93.7%. Now, that makes sense that almost always your percent yield is going to be under 100 because not everything is going to react. But every once in a while, you are going to get something that is over 100%. And so here's what's happening. You see how there are multiple products up here in the equation? Sometimes those products are also mixed in. So in this case, carbon dioxide is a gas at room temperature, so that's just going to go into the atmosphere. But water may not. Water may stick around there. So if your potassium chloride is not dried well, then you could end up with some water weight. And so you could potentially end up with more than 100% yield, which we know isn't possible. You can't end up with more. If I only have 45.8 grams of potassium carbonate, I can't end up with more than what this would react with. So if you end up with more than 100%, keep in mind that may be what's going on. All right, I hope this helped you out, and we're going to have a quiz following up here shortly. So have a great day, and let me know if you have any questions.